Hello, welcome back to my math lab, my math submission video where we will be solving the area of a solenoid z equals 2x squared plus 2y squared between the plane z equals 2 and z equals 8. Now, what does this shape look like if we set y equals to 0, z equals 1? It would be plus or minus. So we would get a shape like this, a parabola, and then if x is 0, that's another parabola in the y direction. Now, the general shape that we are trying to solve for is this between the planes z equals 2 and z equals 8. We are trying to find this surface area. Now, how we can go about this is by creating a parametric function that will draw the plane that we have, where r of u v equals, now since it was circular, in order to draw the circle we will use a scalar to scale the radius of it, sine u, and then another one, cosine u. Now the sine and cosine will create the circle, while the v scales the radius. And what will the z value be? The z value is the function itself incorporated with that. So it'd be 2 and x is squared, so 2v squared, what is that, sine? We can use sine squared u plus 2v squared cosine squared u. Now this is an important step that if you miss it, it screws up the whole integral and takes a lot longer. The sine and cosine is equal to 1, so you just take what is in front, which is the 2v squared, so that can be rewritten as v sine u cosine u and 2v squared. Now we need to find the domain of the v and the u. Going back to this, we would want to solve for 2 and 8. So let y equals 0. This will find the radius. So 2, where z equals 2. 2 equals 2x squared. 1 equals x squared. So plus or minus 1 equals x. And then for z equals 8, do 8 equals ny0, 2x squared, 4 equals x squared. So plus or minus 2 for that. So we also want it to rotate, which is what the sine and cosine do, and u is the variable for that. So if we want it to go all the way around, u will be between 0 and 2 pi, and the radius will be between 1 and 2. The negative does not matter since it's just a radius. The negative in this case would just be direction. So 1 and 2. Now, in order to integrate it, the formula states that the derivative of the magnitude of r partial of u, r partial of v, dA will find the surface area of the solenoid. So let's take some partials. The partial of u for that would be going down v cosine u, v, negative v sine u, and there's no u's in the last one, so that's a 0, and take the partials for r, or v. So it looks like there's only one v, so derivative of v is just 1, so it would just be sine u cosine u, and the power rule for u, and now we just cross them. Cross out the front. Well, so going diagonal, you get 4v, should be a v squared sine u. Don't forget the negative, and then multiplied by 0, negative in front, cross out the middles, and then that's another 4v squared cosine u, and then it's multiplied by 0, and then the last one, a bunch of cosines and sines, but luckily they combine into sine squared and cosine squared from the looks of it. So v cosine squared u plus v sine squared u. And this is the normal vector to that. Woo. We're getting there. So this is also, it goes back to what I said earlier, where this equals 1, so this is really just v. And now we can take the magnitude of this. So square root 4 squared would be 16 v to the 4th sine squared u, plus, looks like it repeats here, 16 v squared cosine squared u, and then that's a 1, so plus what's on the front, v. And again, this can be simplified down to 16 v to the 4th. Oh, almost forgot to square that, plus v squared. Now, this is what this is. And it looks like we can just integrate it. So we're going to take out the v, because it looks like v squared is in both of them. 16 v squared plus 1. And property of square roots allows us to take that out. So let's get to integrating. So we're going to take the double derivative from 0 to 2 pi and 1 to 2 of v 16v squared plus 1. We're going to do du dv. Now we're going to do the du first because the dv splits into 2 where du has a 0, so it should be quite nicer. So 1 to 2 u v squared plus 1 from 0 to 2 pi dv. Now if you see it's a 0, so that's just going to wipe it out. And that will give us from 1 to 2, 2 pi v 16v squared plus 1 dv. Now this is a u sub, but Oh, not UV. Oh, yeah, UV. Oh, cool. So, yeah, this is a U sub. I mean, we used U right there, so we can just use another U. So let U equal 16 V squared plus 1. Take the derivative. That's 32V dV. So dV is equal to du over 32V. Take this, plug it back into there. 1 to 2 to pi of V U du over 32V. V's cancel, and now we just have to integrate the u, which is, it's u raised to the 1/2, add 1, that would be 3 over 2, take the reciprocal, so it would be 2 pi, you can do over 32 from over here, and then 2 over 3. I'm going to replace the u back with this 16v squared plus 1 raised to the 3/2 integrated from 1 to 2. Now it's just a lot of math. So that can cancel that down to 8 times 3, so that's pi over 24 v squared plus 1. So let's go. So 2 into that would be 4, so it'd be 60. Let's do it over here where we can make some room. So pi over 24, 16, 4 squared is 2, 2 squared is 4 plus 1 minus pi over 24, and 16 times 1 is just 1 plus 1, 3 over 2, almost forgot that. Can easily change an answer. So that's pi over 65, 3 over 2 minus, we can just take out the pi's from both of them, minus 17, 3 over 2, all divided by 24. And when you punch that into a calculator, it should give an answer around 59.42. And I will double check. Don't have Wolfram Alpha or any computers to help me. Minus 17 over 24. That gives us an answer of 59.52, and that is the surface area of this between z equals 2 and z equals 8. Thank you.